All right, what we're going to do is solve this here. So what we're looking for is when these two functions intersect and the domain over which we're looking for it to intersect is between negative pi to pi. So we're going to use that equating approach. And again, this would be similar to having two linear functions like 4x take 2 and y equals negative 2x plus 5. And what we do is we let them equal each other. So we're going to say that negative sine 2x equals cosine 2x. Okay. Now, what we're going to do with this one is use this approach here where we're going to eliminate one of these trig functions. Okay. Now, how are we going to do that? Well, the method I'm going to use is I'm going to divide by cosine 2x and divide by cosine 2x. What I'm left with is negative sine on cos equals 1, okay, or sine 2x over cosine 2x will equal negative 1. Now, what we need to know is that is actually equal to tan 2x equals negative 1. So we can go ahead and solve this now using tan. So this is going to be a base angle of pi on 4. When is it going to be negative 1? Well, here at 3 pi on 4 and over here at 7 pi on 4. Okay, so we're going to say that 2x equals 3 pi on 4 and 7 pi on 4. Now, because we've got a domain here of negative pi and pi, what I'm going to do is generate some negative solutions now. So I'm going to go back this way, which is going to be negative pi on 4, all the way over to here, 2, 3, 4, 5, negative 5 pi on 4. X is equal to negative 5 pi on 8, negative pi on 8, 3 pi on 8, 7 pi on 8. All right, and there is my solution. So what's going to happen is that these actually, these two functions here intersect each other at these x values. Now, what's the y value going to be at these points? Well, what I can't do is simply just throw these points into this, because that's like if you use the elimination method and found out that x is equal to, say, 5, you can't just sub this into the function that has already eliminated the y value. Okay, you need to sub it into one that's got the y value in it. So this is like equation 1, this is like equation 2. And I'll show you what will happen if I sub it into this one here that's had the y value eliminated. What's going to happen is I get tan, and let's just choose one of them, 3 pi on 8 times 2 equals negative 1. And that's going to be tan of, that's times 2 is 6 pi on 8, or 3 pi on 4 equals negative 1. And tan 3 pi on 4 is negative 1 already. So we get negative 1 equals negative 1. And so what we're not going to get is a y value. Okay, now we need a y value. So what we've got to do is use these x values here and jam them into either negative sine of 2x or cosine 2x. I'm going to go with this one here. So I'm going to put them into y equals, and I'm going to take this one here. So cosine, that's going to be 2, 3, 6 pi on 8 is, I've just worked that out, 3 pi on 4. My base angle, that is going to be equals negative 1 on root 2. Okay, so this one here is going to be negative 1 on root 2. So let's put that in. That's 3 pi on 8, negative 1 on root 2 is that one there. Now, because when I go around this direction here, I'm going to get to the same point, that's going to be exactly the same solution. So that's going to be negative 5 pi on 8 and negative 1 on root 2. Now, these ones here, I wonder whether they're going to be the same value. I'm not 100% sure. So let's put it into cosine. So we're going to go y equals cosine 14 pi on 8, 7 pi on 4. So 7 pi on 4 is down here, and we're going to get 1 on root 2 for that one. So that's going to be 7 pi on 8, 1 on root 2 for that one, and it will be Same thing for that one. It'll be negative 5 pi on 8 and 1 on root 2. Let's go and have a look at this problem in GeoGebra. So I'll just swing it in and show you what it looks like. Right, so there's our two functions. So there is negative sine 2x and cosine 2x there. So you can see our intersection occurs there, 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 etc., etc. So what I did was I combined them into one function, the tan function, which produced this function here, okay? And what I asked tan is when it was equal to negative 1. Right, so these are all the points where it happened. There it equals negative 1, and you can see that's where the intersection occurs. Intersection occurs, negative 1, intersection occurs, and where was it also negative 1, intersection, etc., etc. Okay, so what that does is it shows us where those intersections occurred. But once I get that, I have to just then put that value back into one of those original functions, whichever one I choose, it'll be true for, to find out what the y value would be at that time.